All right, let's get right into it. Have you ever stopped to think about how all your smart devices, your thermostat, your watch, even some sensor in a factory miles away, all manage to talk to each other? Well, today we're going to pull back the curtain on MQTT and the ESP32. This is the secret handshake, the universal language that really powers the entire Internet of Things.
I mean, seriously, think about that question. We're not talking about a handful of computers plugged into a stable network. We're talking about billions of little devices, many of them running on tiny batteries in places with spotty connections at best. So how on earth do they all stay in sync?
And that right there, that question, it gets us to the absolute core of the problem. You see, the Internet of Things, or IoT, plays by a completely different set of rules. The old ways of networking they just don't work here.
Yeah, look at this. This is basically the 4 big hurdles of IoT communication. First off, these devices are constrained. They have very little processing power, hardly any memory, and they sip battery power. Then you've got the networks, which can be just plain awful. Flaky Wi-Fi, weak cell signals, you name it. And the scale? We're talking billions of devices that need to connect. So you absolutely need efficiency, because every single byte of data you send costs energy and money. They just can't handle the heavy protocols that our laptops and phones use every day.
So what's the answer? Well, thankfully, there's this beautifully simple and elegant protocol called MQTT. And honestly, the best way to wrap your head around it is to think of it like a super efficient digital post office that was designed from the ground up just for these tiny devices.
Right at the center of this whole system is something called the broker. Now, this is the most important part to understand. Devices almost never talk directly to each other. Instead, they all send their messages, their little digital letters, to this one central hub, the broker. The broker's job is to handle all the sorting and delivery.
In this postal system, every device can play one of 2 roles. It can be a publisher, which is pretty straightforward, it's sending a message. Or it can be a subscriber, which means it's told the post office, hey, I'm interested in receiving messages about this specific thing. And here's the cool part. Any device can be a publisher, a subscriber, or even both at the same time.
So you might be wondering, how does the broker know where to send all this mail? Well, it uses something called topics. A topic is just a unique address, kind of like a specific P.O. box at the post office. So a device publishes a temperature reading to the topic factory, sensor, temp, and boom, any other device that has subscribed to that exact same topic gets the message instantly.
And this little chart just makes the genius of it so clear. In traditional networking, you need a direct line. The client has to know the server's exact address. It's rigid. But with MQTT, everything is decoupled. The device sending the temperature doesn't need to know who's listening, or if anyone is listening at all. It just sends its message to the broker. This makes the whole system unbelievably flexible and super easy to scale up.
So to kind of sum up the why of it all, this is it. MQTT uses an incredibly small amount of data. Its message packets are tiny. It has built-in features to make sure messages actually get delivered, and it scales like a dream. This is exactly why it has become the go-to standard for the Internet of Things.
Okay, so we've got the language, this protocol called MQTT. But every smart device needs a brain, right? Something to actually speak that language. And in the IoT world, more often than not, that brain is the ESP32.
This little chip right here is an absolute powerhouse. It's ridiculously cheap, it has Wi-Fi and Bluetooth built right in, and this is the critical part. It has 2 processing cores. Why does that matter? Well, it can use one core just for managing the Wi-Fi and all the MQT stuff, while the other core is completely free to run your main code, like reading a sensor. It's a perfect division of labor for an IoT device.
All right, we have the protocol and we have the hardware. Now let's put it all together. We're going to follow a single piece of data on its entire journey, from a physical sensor all the way up to a dashboard in the cloud.
It all starts out pretty simple. A sensor measures the temperature. The ESP32, our brain, reads that value. It hops onto the Wi-Fi network, and then it publishes that reading to our MQTT broker on that specific topic we chose. And in that very instant, any other service, maybe a cloud application, maybe a dashboard on your phone, that's subscribed to that topic gets the new temperature data no matter where it is in the world. So, what does this actually look like in code? You know, it's surprisingly straightforward. The very first thing you have to do is just tell your ESP32 where the post office is. You give it the address of the MQTT broker. This one line of code is all it takes to point your device in the right direction.
Next up, this is the action shot. This is the line of code that actually puts the letter in the mail. The function esp-mqtt client publish takes our sensor data, packages it up nice and neat, and sends it directly to that factory/sensor/temp topic we keep talking about. It's that simple.
Of course, we don't just want one reading. We want a constant stream of data. So we wrap that publish function inside a loop and then use a little delay function like this vtask delay to tell the device, hey, publish the temperature, wait for 2 seconds, and then do it all over again.
Now look, getting a simple example to blink an LED or send a temperature reading is one thing, but building a real, robust system that has to work reliably out in the real world, that requires thinking like a professional. So let's cover some crucial pro tips.
These are the mistakes that everybody makes at first. If you publish messages too fast, the broker might actually ban your device. If you don't plan for your Wi-Fi to drop and how to reconnect, your device is just going to die. And trust me, using a simple topic like temperature instead of something structured like factory/device133/temp will become an absolute management nightmare once you have thousands of devices out there.
So here's how you do it right. You counter those mistakes with these best practices. You design a smart, scalable topic structure from day one. For reliability, you use something called Quality of Service Level 1, which is basically like asking the post office for a delivery receipt. It guarantees your message arrives at least once. And for any real product, you absolutely use TLS encryption. That makes sure no one can read your digital mail except the intended recipient.
And this quote really just nails it. MQTT is the technology that makes all this possible. It's the bridge. But it's up to us, the engineers and the creators, to use these proper design patterns on a platform like the ESP32 to build systems that are actually robust and won't fall over in the real world.
So there you have it. The secret language of our smart devices maybe isn't so secret after all. It's really just a clever, efficient system that was purpose-built for our massively connected world. So now that you know how they talk, the only real question left is, what are you going to build with it?